Alrighty, guys. So this is unit 4. Listen up. This is unit 4. We are on lesson number 6, I believe, today. We're going to be talking about scale drawings and models. We're on page 18. And these scale models and or scale drawings and models are very similar to the proportions that we were just setting up in the last few um, examples. So rather than talking about different examples like how many pumps can pump out a certain amount of gallons of water, or how many um, adults are in a certain ratio with students. These are going to be focused on more of a real world example of um, creating models and drawings, sort of like architecture does, right? So sort of like a real world example of where we see proportions. Okay. So jumping right in, we see a scale drawing or a model is used to represent an object that is too big or too small to be shown for its actual size. The dimensions of the object on a scale drawing or model are proportional. See, this is very important. This is what allows us to use proportions. If they weren't proportional, we couldn't use them. Proportional to the dimensions of the actual object. So, again, if you guys have ever done a Lego, like a car Lego set, obviously it's not a life size, right? It's a scale model of it, right? It is to the correct dimensions, right? So like if the car mirror was 10 inches or whatever, the model might be 2 inches, right? So it's still correct details and dimensions, but it's just scaled down, right? Yes. I believe it. I believe it. Alrighty. So, you guys, the scale that we're talking about when we say scale drawings, it's actually a ratio, right? And we've learned about these ratios. It's one thing on top, one thing on bottom that are related to one another, right? So, the scale is the ratio of the size of the model to its actual size, okay? So, I'm going to actually use this line right here to show you the top and bottom of our fraction, right? So, what we do, again, it says the size of the model. So we put model on top and we put the actual size on bottom. Okay. So that's our ratio that we're going to be using, model over actual. Okay. A scale can have the same units or different units. And you can also use a scale to find a missing measure on the model or on the actual object, which is what we were doing with proportions that had variables, right? We were looking for a missing piece. So let's take a look at some of these examples and jump right in. Okay. Number one, Eric is planning to build a raised garden. He sketches a plan with a scale of 1.5 inches to 4 feet. If the garden has a width of 4 inches on the drawing, what would the actual width be of the garden? Okay. So we're going to be using keys just like we were in word problems yesterday. And again, our key for today is always going to be model over actual because we're talking about scale drawings. Okay. So we have model on top, actual on bottom, right? That's my key. Okay. I want to encourage you to write that down so that you don't mix up numbers or move them in the wrong spot. Okay. So he sketches a plan that has a scale of 1.5 inches equals 4 feet. Okay. So the 1.5 inches is the scale drawing, right? It's the model. So I'm going to start that on top, 1.5 inches, and that is equal to 4 feet in the actual world. Okay. His garden, and think about it conceptually. Are you going to have a garden that's this long, like 1.5 inches? Of course not. Of course not. It would be more like 4 feet. It'd be something that's longer. So that's why we can kind of think about these problems realistically, right? Obviously, this is the model version, not the actual. Yes, Hudson.
Window gardens that are super tiny.
Well, then
That's
you could have a scale. Yes, yes, there could be some exceptions, but this is, yes,
Wow. Yeah.
for sure, for sure. If we were drawing so the thing is if it was really small, Dean, you wouldn't actually need to draw a scale drawing. You could actually just draw something that size on your piece of paper, right? So scale drawings are for things that are, look, too big or too small to be shown, right? So if you use something that just is small, like a little garden, you wouldn't really need to use a scale drawing, okay? But in this case, we're using a scale drawing because we're talking about an actual big garden, okay? So does everybody see that model over actual? And then over here, do you have a question real quick, Lauren, or no? Yeah,
Okay, enough with the what ifs, guys.
it's all right. It's all right. It's not bad to ask questions. So a circle garden, it's a little bit more complex, but it's something that we probably won't be touching on in here. You would just have to measure it in a different way, if that makes sense. I'm sure you could still use this formula here, model over actual. All right. Yes, Gavin. Okay, same thing, same thing. Alrighty, if the garden has a width of 4 inches on the drawing, so you guys, where does 4 inches go? On top or bottom? Top, because it's the drawing, it's the model. Okay. What would the actual width of the garden be? So that's our X. Does everybody see that? Okay, so now we have a proportion set up just like we have the last few days. Okay, so again, 1.5 times X and 4 times 4. 4 times 4. 4 feet, 4 inches. It's not point anything, okay?
What would it be or inches?
Well, the thing is with these ratios, they can have the same units or different units. They don't have to be identical. Just like if you think about the problems from yesterday, remember how we had 2 pumps on top and 1,300 gallons on bottom? Those are different units, right? Pumps and gallons. So same thing here. We have inches and feet. It still works out as we're doing our proportions. But it is important where you put them, right? Because if I put my X up here, I'd be looking for inches and not feet. You need to make sure they are the same as you look across. Okay. Can anybody tell me what our answer is here? Does everybody agree with that?
Well, it's 10.6 repeating 7.
Yeah, repeating.
I was just asking because I didn't have a calculator out and I wanted to make sure that we were getting the right value because I know there's been times when I've written down a number in pen and then it's wrong.
Eating.
All right. Yep, it's repeating. Alrighty. So we're gonna move on to the next one. Yes.
Is repeating at the end of the repeating will just be the next biggest number.
You can take a repeating number and round it up. Yeah. So if it was 0.7 repeating, you could do 0.78 if you round it up. The calculator. Yeah, because your calculator only shows you if like what 10 digits or something, or maybe a little bit more than that. It's not going to show you a million 0.66. You know what I mean? All the way. So
Do this thing where like where we did the thing, it's like 10 times 8.5 squared. That thing we did where scientific notation. Sometimes when you do that, it'll give you the first couple of digits and then behind it it'll just say times
yeah,
10.
yep. And that's a nice thing that your calculators will do. And that's partially because they are scientific calculators, right? They kind of simplified numbers down to scientific notation, just to simplify numbers in general. Okay. So again, you guys, this is another model over actual. So we're going to start with our key, and then we're going to read through the problem. She wants to enlarge a photograph to make it into a poster for her room. The photograph is 6 inches tall. Okay, do you think the photograph is the model or do you think the poster is the model? The one that's smaller is usually going to be your model. So the photograph is the one that's listed first and it's smaller. It is 6 inches. Okay. The poster that's going to be created is going to be a scale of 4.5 inches to 2 inches. Okay. So we see that we have a scale here. Which one of these is smaller? The 2 inches, right? So the 2 inches is talking about our model. And the 4.5 inches will be the poster itself. Okay. I know. So that one is a little bit tricky. Do you just have this flip-flopped?
No,
Or do you have some of the numbers flip-flopped?
bottom and 4.5 on the, or 2 on the bottom and 4.5 on the top.
That should work out the same though. Yep. Because Lauren, just do your multiplication and see how it works out. You're still gonna have 2 times x. And you're still gonna have, did you have 6 times 4.5? Yeah, you're still gonna get the same value. Yep. So 13.5 inches is the height of the poster. Okay. And again, the way to think through problems like this is the photograph is going to be smaller, right, than the actual height of your poster, right? Because the photograph is the model, it's the smaller thing. Okay. Let's take a look at number 3 here. We have James, who is building a dollhouse that is proportional to its own size, or his own size, or his own house. Sorry. Hey, it's just an example. Hey, it's just an example here. He's using a scale of 0.5 inches equals 1 foot. Hey guys, let's try to stop our side conversations. Thank you. Okay, so we have model over actual. Which one's bigger? 1/2 inch or 1 foot? 1 foot is larger, right? So 1 foot is going to be on the bottom. That's going to be our actual size. And the 0.5 inches is going to be on top as our model, right? So our model in this case is going to be the dollhouse, and the actual is going to be his own house. Okay? Yeah, for sure. Okay. And then over here it says if the dollhouse is 12.3 inches tall, how tall is his actual house? Okay. So we know that doll or the model is going to be on top, so 12.3, and we're looking for that x value, right? And you guys can do that kind of quick trick, right? If you take 1 times 12.3 and divide it by 0.5, that will give you your answer, okay? What'd you guys get as an answer here?
Wait, why is it flip?
Sometimes I will, it's just something that I do. Another way you can write it, Ollie, if you wrote this, that's totally fine. I just sometimes, do you see how like this equal sign allows you to flip them because it's still equal, right? Either way that they are.
12.3 times.
Yep, divided by.
I did divide by.
So not 24.6, yep. And that is feet, right? Because that bottom part is feet.
Not 24.
I read it wrong.
Yeah, it is. 12.3 divided by 0.5.
12 divided by.
0.5. There you go. Did you do divided by 5? Is that what happened, Lauren? Gotcha. Alrighty, number 4. We have a drawing that has been enlarged using a scale of 1 inch equals 1.5 inch. Okay, so the model is always going to be the smaller one. Do you guys see that? How that's kind of been the case? So 1 inch needs to be on top, 1.5 inches is on bottom. Okay, again, the reason for that is because the model is always going to be smaller. Okay, if the original drawing was 4.6 inches, how long is the enlargement? You guys, what does the word enlargement mean? It's actual, yes, but what does the word enlargement mean? Just like
It's bigger.
it's bigger, right? So enlargement has to be on the bottom. That's what we're looking for. And that 4.6 would be on the top. Okay. So now we can do our cross multiplication here. We have 1x equals 6.9. Is that what you got? Okay, 6.9. You guys, 1x is just the same as x, right? So we already got our answer. There was nothing we needed to divide by. You can divide it by 1 if you want, but again, anything divided by 1 is just the same thing. Okay. Do you guys have any questions on those first 4 before we keep going?
Dollhouse and also.
Do we have any questions that are focused on the math problems and how to work through them? Hey guys, stop. Thank you. 1 second. Any questions on these first four? We'll get there eventually. I'm not sure yet. Okay. Alrighty, we're gonna flip the page and we're gonna do some more examples here. Okay. All right. We have the Mount Rushmore Monument is 60 feet tall. The model of the monument is sold at the gift shop. If the model was made using a scale of 1 inch equals 40 inches, how tall is the model? Okay. So again, model over actual. It tells us that the monument, the actual monument, is 60 feet, right?
Mhm.
The model, it says, is 1 inch for every 40 inches. But before you guys write 40, what do we have on bottom here? We have feet, right? So I can't use 40 inches right here. Convert it to feet. How many inches are in each foot? Yes. So if you just take 40 divided by 12, it gives you 3.3 repeating. So if you want to, as you put that into your calculator, if you want to just hit that 3 button a few times after the decimal, if you round it a little bit, that's okay. All right. And then over here,
Is it 3.3?
wait. Okay. Alrighty. So we are going to take this a little bit of a different way. Okay. Listen up, listen up. Okay. Alrighty, guys, let's listen. Thank you. So our model here is 1 inch equals 40 inches, right? And what it gives us is that the actual is 60 feet. And we're going to actually convert that into inches, which is 720. And we're looking for how tall is the model. Okay. So we're going to use this instead. We're going to be, again, changing our feet into inches because then we don't have to deal with that decimal there.
Yeah, I divided it almost one, so I got 5.
Yeah, 60 feet is totally 5 inches.
Okay. So, wow, that's not helpful. 18 inches. There we go. Okay. So again, 720 times 1 is 720. 40 times x is 40x. And when we divide by 40, you get that 18. Okay.
When you do it with the big numbers, you get 18.8.
Oh, does it not round nicely? Alrighty. I know that one's kind of tough.
18.8.
Alrighty, guys. I want to move down to number 9, 10, 11, and 12. Okay. We're going to be finding the scale of the drawing or the model. Okay. So the first step is to write a ratio of the model length to the actual length. So again, think model over actual, just like before. And we're going to simplify these ratios so that the numerator is 1. Okay. So essentially, what you're going to do is divide the numerator and the denominator by a number in order to get 1 at the top. Okay. So it's nice for these first two, they just give you model and actual, right? So what we're going to do is we're going to write down the model, which is 6 inches, the actual, which is 72 feet. You guys, what number am I going to divide them both by to get 1 on the top?
6.
Exactly. If I divide by 6, I get 1 over 12. So that means for every 1 inch of my model, that represents 12 actual feet in real life. Okay. For these problems, yes, they're just asking us to find the scale. And this is our scale. 1 inch equals 12 feet. Okay. We're on page 19 at the bottom. No worries. Okay. So we're going to do that again. We have 36.
4.5.
Yep. 4.5 kilometers. Okay. What do I need to divide top and bottom by to get 1 on top? No. If I divide this by 4, it will not give me a 1 on top. Divide it by 36. The only thing we can divide it by to get it to be a 1 is itself, right? So I get 1 centimeters, 0.125 kilometers. Okay. So every 1 centimeter on my model represents 0.125 kilometers. Okay. It is 9:40. All right. If we look at number 11, we have a poster that was made of a 6-foot tall musician. The musician on the poster is 20 inches tall. What is the scale that was made to make the poster? Okay. So again, model over actual. All right. Is the musician 6 feet tall in real life or 20 inches tall?
6.
6 feet, right? No, he's 6 feet. So 6 feet goes on the bottom, 20 inches goes on top. What do I need to divide to make 1 on top? 20, right? It's always just going to be exactly what you see on the top.
0.6 divided by
So 1 inch. What is 6 divided by 20? No,
0.3.
wait. Oh, it is? Oh, sorry, you were right. 0.3? Exactly 0.3?
Yep.
Oh, perfect. Okay. Sorry, my answer key was off. It says 24.6 feet, which makes no sense at all. Okay. I was like, no, it's 24.6. No, it's not. Okay. And then this last one here, we have model over actual. A model airplane is 18 centimeters long. So the model is 18 centimeters. Does everybody see that? And the actual airplane is 60 meters long. Okay.
1.3 repeating.
And how did you do that?
60 divided by 18.
Yes. Okay. So 1 centimeter on top and 3 1/3 meters. Okay. Again, 0.3 repeating is 1/3 as a decimal. Okay. I know that lesson, maybe some of the problems didn't go exactly as we planned, but I hope that you guys feel good about creating a proportion and knowing model over actual, okay? So model is always going to be the small number and the actual is always going to be the bigger number, okay? So on facts, I'll have that homework, so just double check facts.